Hello everyone, welcome back to PE Academy. So far we've been looking at mesh analysis. So we've looked at 3 examples and this is example 4. So if you are new here and you've missed the previous examples, I'll leave a link to it in the description of this particular video. And if you are yet to subscribe to PE Academy and you enjoy seeing content under electrical engineering, electronics engineering and engineering drawing, do make sure you click on that subscribe button at the lower right of your screen. So go ahead and click on that subscribe button and let me know in the comment section if you have just subscribed. Alright, so thank you very much if you have just subscribed to the channel and say welcome to PE Academy. Alright, so this is example 4 and this is the circuit we are going to be solving. Look at the question that is attached to it. It says, find the value of V if the current in the 3 ohm resistor is equals to 0. Now this is V, the voltage source. We have 2 voltage sources, we have 5 volt here and we have another voltage source here. But the voltage source here is unknown and that's what we are asked to find. The question also gave us another information that the current through this 3 ohm resistor is what? Is 0. It said find the value of V if the current in the 3 ohm resistor, this is the 3 ohm resistor right here, is equals to 0. So now let's solve this. So we are still going to be using mesh analysis, and like I said, if you are dealing with mesh analysis, one of the concepts to use is the Kirchhoff Voltage Law. So we are also going to apply all of the principles I've discussed at the introduction of mesh analysis on how to answer questions under mesh analysis. So the first thing is for us to identify the the nodes. So these are the nodes. And by the way, if you are not clear what nodes is, or you want to know more about the difference between a node, branch, loops, element, and all of those things, I've done a video about it. You can check the description and then you'll find a link to that video. So let's call this A, B, C. Let's call this node D. Let's call this point E, F. Let's call this G, and then H. So having done that, now let's take our direction. We have from this circuit we already have 3 meshes. We have 3 meshes. This is 1, 2, and then 3. So now let's pick the direction of our current. So like I said, I do like to start with a clockwise direction. So let's take our current to be flowing in a clockwise direction for this mesh 1. So this is mesh 1. So this is my mesh 1, and then the current, let's take the current here to be I1. So this is for mesh 2. So let's take the current here to be I2, and this is mesh 3. Let's take the current to be I3. So this is mesh 3. So let me just write M3 because of space. Alright, so now that we've taken the position of our the direction of our current, so let's go ahead and add the polarities. So starting with the voltage source, here is going to be positive and negative. Don't forget the longer side is positive. So this is also positive, then negative. So now with mesh 1, let's go ahead to add the polarities to the resistors. So this is going to be plus and minus in this direction. This is going to be plus and minus. So now let's go to that of mesh 2 for current 2. This is going to be plus, minus. This is going to be plus, minus, plus and minus. So for the mesh 3, plus, minus, and then plus, minus. So if you have been following, I want to believe you won't have problem with adding polarities to circuits under mesh analysis. Alright, so you can also, if you have been following this video, if you've watched the last 3 examples, you can test your knowledge on mesh analysis by pausing this video and attempting the question, and let me know in the comment section if you're able to arrive at the final answer, so when I'm done solving it. Alright, so now that we've done that, so the next thing is to apply Kirchhoff voltage law to each of this mesh. So to start with, so we are going to be starting with mesh 1. So that's going to be mesh 1, and the path for mesh 1 is A, B, that's A, B, G, H, and back to A. A, B, G, H, and back to A. Alright, so in applying Kirchhoff voltage law, so let's start from point A. So for this 1 ohm resistor, so from plus to minus, that's going to be minus 1 ohm multiplied by the current I1. So that's going to be 1 I1, but you can also indicate it as I1. So now let's continue. So between B and G, we have a 2 ohm resistor. So from positive to negative, and through because of the current of I1, that is going to be minus 2 I1. We also have another current I2 flowing through it, but in this direction, we are still taking this clockwise direction for current I1. This is going to be plus to minus, minus to plus. That is going to be plus 2, but we are taking the current from I2. I hope that is clear. From G to H, there's nothing here. Then from H to back to A, we have a voltage source that's from minus to plus. That's going to be plus 5 equals to 0. Now, if you are to simplify this, now before we simplify this, let's look at this that is given here. It said find the value of V if the current in the 3 ohm resistor. We are told that the current in the 3 ohm resistor, look at this, that it is equals to 0. You have to pay attention to that. What it basically means is that now you see this 3 ohm resistor, they said the current that is passing through it is what? Is 0. And if this same 3 ohm resistor is independent, that means the only current that is passing through it is I2. Are we following? If you have followed the previous example, you should have full understanding of what I'm saying. The only current that is passing through through the 3 ohm resistor is I2, and we are told that the current that is passing through it is already 0. So what that means is that you can just notice somewhere that what that simply means is that our I2 is equals to 0. That is what it means. That the value for our I2 is 0. So with the knowledge of that, so anywhere we are solving in each of these mesh, if you come across I2, we will take the value to be 0. So now let's apply that here. So in simplifying this, we have minus I1 and minus 2I1. So that is going to give us minus 3I1. Now remember, then plus 2. I2, we know that it's 0 into bracket 0 plus 5 equals to 0. So we are going to be having minus 3I1. So 2 multiplied by 0, that's 0. Then plus 5. So this plus 5, if you take it to the other side of the equals to sign, we are going to be having minus 5. So what we do now is we are going to divide both sides by minus 3. So divide both sides by minus 3. So we are going to be having minus 3I1 is equals to minus 5. So if you divide both sides by minus 3 and minus 3, so this is going to be cancelled this out. So you are going to be left with I1 is equals to, so this negative is going to cancel out. So 5 divided by 3, if you type that in your calculator, you'll be getting 1.667. And then don't forget your units, amperes. So that means the value of I1 is 1.667 amperes. But we have not done yet. That's not the final answer. That's just what we are able to get after simplifying mesh 1. So now let's go to mesh 2. So for mesh 2, so the path for mesh 2 is B, C, F, G, and back to B. So let's indicate it. That's B, C, F, G, and back to B. So applying Kirchhoff voltage law to mesh 2. So taking it from point B, so the first element you're having here is this 3 ohm resistor. So we are going to be having from positive to negative, that is going to be minus 3I2. So moving forward, we come here from positive to negative for this 4 ohm resistor with current of I2, that is going to be minus 4I2. Then also from negative to positive, because of the current of I3, that is going to be plus 4I3. So from F to G, there's nothing here. And then from G to B, so the first we're having from positive to negative, the resistor here, 2 ohms due to I2, that is going to be minus 2I2. So we also have a negative to positive due to I1, that will be plus 2I1 equals to 0. Alright, so let's continue. So let's first of all simplify this. We're having we're having 2I1. So let me just arrange it in order of the currents. So 2I1. Then we also have minus 3I2, minus 4I2, and then minus 2I2. That's going to give us 4 plus 3, that's 7. That's going to be minus 9I2 plus 4I3 is equals to 0. So we just simplify this into this. So don't forget, our I2 is 0. So that's going to give us 2I1 minus 9 into bracket 0 plus 4I3 is equals to 0. So we are going to be having 2I1. So this is automatically cancelled out. Minus 9 times 0, that's 0. Plus 4I3 is equals to 0. Now, with what we are having here, we should now recall that I1, okay, let me just use my red pen to write that. So recall that I1, we've gotten our I1 to be 1.667 amperes. Don't forget, after solving the mesh 1, we arrived at our I1 is 1.667 amperes. So what we are going to do is, we are going to substitute the value of I1 into this equation, into where we are having I1, we are going to replace it with 1.667. So in doing that, we are going to be having 2 into brackets 1.667 plus 4I3 equals to 0. Alright, so because of space, I'll have to rub this up. So if you are writing it down, you can just write this down, or you screenshot it on your device, so that we can have more space to continue with mesh 2. Alright, so let's continue. Remember, after solving mesh 1, we are able to get I1 is 1.667. So I still have this information here because it's still very helpful. So now if you should simplify this, now we are having 2 multiplied by 1.667. So if you type that in your calculator, that should give you 3.334. So we are going to be having them plus 4I3 equals to 0. So what we are having here, let me bring it here. So this is 3.334 plus 4I3 equals to 0. So now if you try to make I3 the subject formula, we are going to be having 4I3 equals to, now if this 3.334 should come to the other side of the equals to sign, we are going to be having minus 3.334. So what we do here now is divide both sides by 4. So divide both sides by 4. So in doing that, we are going to be having 4I3 divided by 4 is equals to minus 3.334 divided by 4. So this 4 can cancel out this 4. So what will be left is, which is I3 is equals to, so minus 3.334 divided by 4. So that will give us minus 0.8335 amperes. Don't forget your units. So in simplifying mesh 2, this is what we are having. So we have gotten our the value of our I3. So let me also write it somewhere here. So we've gotten our value of I3 to be minus 0.8335 amperes. So that is it from now. Let's go ahead and do that of mesh 3. So I'll need to rub this off so that I can simplify mesh 3 in this space. So you can also take notes. Alright, so I've indicated the value from the mesh 1, we're able to arrive at I1. In simplifying mesh 2, we're able to get the value for I3. So now let's go to mesh 3. So mesh 3, now the path for mesh 3 is C, D, E, F. C, D, E, F, and then back to C. Now don't forget what you are trying to get. You are trying to get the value of V here. We are trying to get the value of V here. So now in simplifying mesh 3, so applying Kirchhoff voltage law, let's start from C. From C to D, we have one element, which is the 5 ohm resistor. So from positive to negative, that is going to be minus 5I3. So from D to E, we have a voltage source, and this is what we are looking for, but we don't know the value. But so that's from positive to negative, that is going to be minus V. So let's continue. From E to F, there's nothing here. From F to C, we are having a 4 ohm resistor. So from positive to negative, that's going to be minus 4, and then the current is I3. Also, we also have been taking it from positive to negative due to the current I2. So that's going to be plus 4I2, and then back to C equals to 0. So now let's simplify this. So that is going to be giving us minus 5I3 and then minus 4I3. That's going to give us minus 9I3. And then we're also having plus 4I2. Now this minus V, we can take it to the other side of the equals to sign, so that it should become v. By the time it takes it to the other side, become positive. So now let's simplify this. Now remember that I2 is 0. Don't forget from the question, I2 is 0. It was not stated, but if you analyze it in your circuit, you know that I2 is 0. So now let's substitute that. So you're going to be having minus 9I3 plus 4 into bracket 0, that equals to v. So this is 0. So in solving this, that means we are having minus 9I3 is equals to v. So you can also write it like this, as v is equals to minus 9I3. Are we following? So that means our v is equals to, now remember that I3, we've gotten the value of I3 to be minus 0.8335 amperes. So we'll substitute the value of v into this equation. So let me write it. So substitute the value of I3 into the above equation. Now, so in doing that, we are going to be having v is equals to minus 9 times minus 0.8335. So if you multiply this minus 9 times minus 0.8335, we are going to get our v to be 7.50 amperes. And with that, we've been able to find the value of v. We've just find the value of b, that in this current, when the 3 ohm resistor, and when the current that is flowing through the 3 ohm resistor is 0. So this is the voltage that will be here. So before we go to example 5, I believe you find value in this video. If you do, please give it a thumbs up. And if you are yet to subscribe to PA Academy, please do so. Click on the subscribe button. It's all at the lower right of your screen. It's absolutely free to subscribe. Then you can also check out our website, paacademy.co. paacademy.co. So if you have any questions with this example or any comments, just leave them in the comment section below. I reply to all comments. So thank you very much for watching, and I'll see you all in example 5. And before we go, at the beginning I said you should attempt the question before I solve it. So if you attempt the question and you're able to arrive at your v is 7.50 ampere, sorry, we are dealing with volts, so it should be 7.50 volts, not amperes, volts. All right, it's good that I was able to get that on time. So it's volts, so always pay attention to your unit. Always make sure you indicate your unit and your unit is right. So that's 7.50 volts because we are looking for the value of v. All right, so if you are able to arrive at the answer, before watching the video to the end, do let me know in the comment section. And if you are not, let me know where you get stuck, and then we can interact in the comment section. All right, so thank you very much, and I'll see you all in example 5.